Today we just spent the last 8 hours clambering up and down Mount Greylock, which is the tallest mountain in Massachusetts. Spans a couple thousand feet from the bottom to the top, and we've been collecting samples of glacial boulders to date when they were dropped by the big ice sheet that melted out of New England 10 or 15,000 years ago, to figure out when exactly that ice sheet thinned out of the top of the mountain all the way down to the bottom. So New England used to look like a huge block of ice, and there was nothing more to it than that. Basically everything in the landscape was completely covered, inundated by just ice topped by snow. So picture Antarctica today in your mind, and that was New England 20,000 years ago. Then climate started to change, things warmed up, the Earth tilted over a little more on its axis slowly, which it does over long cyclical timescales. A little more sunlight started hitting New England and Canada, and the ice started melting. And then through time, the ice started to retreat northward through New England up into Canada, and also started to thin downward, and poured all that water into the ocean and caused sea levels to jump up. The end of the last ice age was the last big global warming event on the planet, and we're now on sort of the doorstep of the next big one that's going here. But today, it's really all about rising greenhouse gases, and we know that through a whole series of different lines of evidence that have been discovered over the last several decades. So this time the cause is different, but the way it plays out, warming planet, melting ice, rising sea levels, it's the same bottom line. So we're trying to figure out when exactly the rocks were dropped by the ice sheet as it was melting out of New England, and when those rocks first basically saw the light of day as the ice melted away and left them there on the landscape. And so the way we do this is we measure how much of a rare isotope called beryllium-10 there is in the surface of the rock. And the way this works is that as soon as rocks are dropped on the landscape, glacier melts away, that rock starts getting bombarded by cosmic radiation coming from space. And as that radiation hits the rock surface, it starts making beryllium-10. The longer the rock is sitting out there, the more beryllium-10 is going to get produced. What we would imagine here is, as the ice age was ending, the top of the mountain was the first part to get exposed as the ice surface melted down into the valley. So we would expect the rocks up here at the tip to have more beryllium-10 than the rocks do at the bottom that didn't thaw out of the ice until later. And we can look at the difference in the amount of beryllium-10 from boulders at the top of the mountain to the bottom to figure out how fast did that happen. That is the single biggest wildcard question mark of future sea level rise. How quick can an ice sheet pour so much water into the ocean? And we have two huge ice sheets today, obviously none in New England, this isn't what we're concerned about today, but you head up to Greenland, you head up to Antarctica, and there's gigantic amounts of ice there, enough to raise sea level by hundreds of feet. And so the question is, how fast can that happen?